This is the third video to accompany my NI Week 2015 session, Don't Panic, a LabVIEW Developer's Guide to Test Stand, technical session 6421. So this video is designed to demonstrate how we can use the DQMH, the Delacour Queued Message Handler, in order to facilitate transitioning our LabVIEW code into a test stand environment whilst retaining some of the benefits of LabVIEW, namely a great debugging environment, whilst taking advantage of test stands out of the box features such as great report handling, great report writing, database logging, user management, all of those things that we end up implementing anyway in test solutions. Rather than rolling our own LabVIEW based solution to solve those problems, let's find an architecture that allows us to use test stand and retain the benefits of both environments. So there are numerous videos on this YouTube channel, the Delacour YouTube channel, www.delacour.com products. You can see some links to videos regarding the Delacour Queued Message Handler. It also ships with some examples, so if you install the DQMH, the Delacour Queued Message Handler, via the LabVIEW Tools network, when you restart LabVIEW, you should see within the LabVIEW help, you can search for DQMH. We've got some pretty extensive examples in there. If I look at the example code, for example, let's go to find examples, and we search for DQMH. There are some examples in here that not only show how to use the DQMH from within LabVIEW, but also feature some test stand examples as well. I won't go into these in this video, but by all means install the DQMH and browse those examples and have a play around with them and see how they work. So the DQMH is an architecture that allows the creation of asynchronous modules that hold state. They have their own private data, and in order to affect the behaviour of the modules, you need to send messages to the module in order to request that it does something, or to receive a message or a broadcast back from the module informing you that something happened. We refer to those as events because under the hood we use LabVIEW user events in order to provide that mechanism. The DQMH toolkit also comes with a number of great scripting tools to allow the automation of the creation of those events and the destruction of those events. So for any of you that have used user events in LabVIEW, you'll be aware that creating them and destroying them, it can be a little bit tedious if you're doing this repeatedly. So we've got some great scripting tools in the toolkit to facilitate that. Let's go ahead and have a look at our example where I want to show how we can use the DQMH in order to provide a great architecture that gives the benefits of the LabVIEW environment whilst also allowing you to take advantage of the features of test stand. So in this particular example, I've got a LabVIEW project called Functional Test. My LabVIEW project consists of a power supply driver and a DQMH module that can make calls on that power supply driver. So my driver consists of a LabVIEW library and a number of method VIs. So these are just members of that library, and these will typically be the VIs that write Skippy commands either via serial or via GPIB to an actual box type instrument that we might have sat on our bench. And typical of a power supply, the things that we might want to do: set the current limit, set the output state, set a voltage level, measure the drawn current, identify the instrument, or reset the instrument. So these are the low-level driver calls that we want to make. However, unlike in the previous video, we don't want to be making naked calls to these driver VIs from test stand. That can often result in an overly granular test sequence, and it involves us managing the references, managing those visa ref nums within test stand, and that can get a little tricky. We don't want to be doing that. It increases the chance that we'll make a mistake and make a call to the wrong instrument, for example. So we have this driver library, and we also have a DQMH module called Power Supply. The DQMH module's been built using the scripting tools that we provide in the DQMH toolkit. I've provided a number of public API requests, things that we might want to request that our power supply module does. For example, we might want to show its front panel or hide its front panel. We want to start the module and stop the module. We might want to set the visa reference. So I mentioned earlier in the video that a DQMH module has state. It has private data, and the only way to interact with that private data is to fire an event, send a message to the module. Part of the state data in this particular example is the visa reference. So we have an event called update visa reference. Update visa ref num, where we send a visa ref num to the module, and then it holds that reference, and it uses that reference for any future communications with an actual instrument. So if we then call the update voltage level event and we supply it with a new voltage level, the module will use the visa reference previously sent in order to communicate and to action that update voltage level behavior, that method. So our module has state, and we interact with it using events. So let's show that in action. I'm going to use my test power supply API. So every DQMH module that is created using the toolkit comes with a handy tester, and this is really allowing us to use the LabVIEW environment to its maximum effect. So if I run the API tester and say start module and show its front panel, I've now got an instance of my power supply module running asynchronously, and I can interact with it. So I can set its visa reference, for example. Let's assign it to COM1, and we saw that now the power supply is communicating via COM1, or the power supply module is communicating via COM1 to some hardware that we might have attached to our system. And what this allows me to do is prove out the API of my power supply module, make sure I'm calling the right driver, lower level driver VIs, and that they're behaving correctly. So I can do an awful lot of my debug and my integration type work in the LabVIEW environment to prove out this API. So let's set the voltage level to say 1.5 volts. We can see the voltage level's changed. I would then be able to verify on actual hardware that the voltage level had changed and that I was calling the right lower level driver VI. Let's change the current limit to 0.5 amp, and we can see that the current limit has changed as well. Okay, let's go ahead and stop that module. Now, if you watch the videos regarding DQMH via the YouTube channel or via the Delacorp website, you'll see that we have two different types of DQMH module. We have a clonable module where we can have multiple instances of a DQMH module running asynchronously, each one being uniquely addressable, or a singleton implementation of the DQMH, where we guarantee that you only have a single instance of a DQMH module running, and trying to make calls to start DQMH module of a singleton. If the module is already running, then we just return the reference to the already running instance. In this case, we might have multiple power supplies in our test system, so it is a clonable module. So let's go ahead and stop that module, and let's stop our API tester. Now, before I actually start calling this from test stand, I just want to give an example of the power of the scripting tools within DQMH. So I'm going to go ahead and add a new event, some new functionality to our module. I'm going to call the set output state. So the first thing I need to do is provide a boolean on the front panel of my API tester. And let's call this one output state. And I'll save that. And I'm now going to use the scripting tools to add a corresponding event to my DQMH module. So I go to Tools, Delacorp, DQMH, Create New DQMH Event. The tools scan the open project and identify that I've got a power supply.lvlib DQMH module. I want this to be a request event. We support 4 different types of event in the DQMH toolkit. Request is an outsider asking a module, requesting a module to do something. A broadcast is an outbound message from the module saying, hey, I did something, I'm letting the outside world know. Request and wait and reply is a synchronous or blocking call where we ask a module to do something and then wait for a response. And round trip is an asynchronous, non-blocking call where we ask a module to do something, we expect to hear back from it, but we're going to go off and do other things while we're waiting. So we're going to have a request event, and let's call this set output state. And its data type is going to be a Boolean output state. Okay, we say OK to that, and the scripting is going to go off and create that event. And I'll pause the video while we wait. Okay, welcome back. So our scripting has now gone ahead and created the corresponding event to the set output state, and now it's a case of us just assigning that those event cases to the Boolean control on my front panel of my API tester and on the user event in the DQMH module. And the toolkit's provided some helpful hints on what I need to do. So I've got these blue comments on my block diagram telling me where I need to add code. So in this case, I just need to assign that event case to the output state Boolean that I created a few moments ago. And we're going to take the new value of that and wire that in. My API tester can now fire that event corresponding to the output state or set output state event. Let's go ahead and close that. We now need to register for the user event at the DQMH end. So edit events, set output state, and there's a little bit of wiring to do. We like to ensure that the user does this final bit of wiring just so they're familiar with what the scripting has actually done. And then let's display that output state. And I'm going to change that to one of those pretty silver controls before anybody gets too upset. There we go. Now we have output state being held in the private data of this particular module. So let's go ahead and populate that with the new value corresponding to the event that was just fired. And we need to make a call to the update panel state to update that Boolean control. I'm going to cheat and then if I go to the update panel, let's just go in and wire the indicator directly in this case. Let's just check. And we need to make a call to the actual instrument driver at this point to actually interact with our instrument. So another piece of information that we require from our module private data is the visa reference. So let's go ahead . If I look back into my project, find the set output state VI, the low level driver VI, and accidentally moved that. Let's drop this down here. And finally provide the output state that we require. So now we're going to make the calls and it would appear appear that we got something miswired. We've probably got, there we go, we need to change that to a control. Schoolboy error. So now we've got an event, an API method that we can call to communicate directly with our instrument. And the scripting tools did an awful lot of that legwork for us. So now if I find my API tester, run the VI, start the module, show its front panel, I can now interact and select and set the output state of my power supply. So I'm able to fully prove out the API using LabVIEW, using this API tester, fully prove out the API of my DQMH module. It is responsible for handling state, so handling its own visa reference, so I don't need to worry about passing the correct reference in and out of test stand. So now, using the very same API methods that I've been using from my API tester, I can now create a test stand sequence that makes direct calls into that DQMH module. So let's go ahead and launch test stand. And let's launch our power supply DQMH module. We then add a step, or let's define that step first. So let's find the start module. We need to then wait for the module to start. So that we can synchronize events. We don't want to be firing events before the module has started. So we need to communicate between these two modules by passing a boolean. So let's create a boolean locally called module sync. This just ensures that our module has started before we register for any events. So let's assign that to a local variable. And now we can make calls on the public API of our module. Let's save it somewhere to the desktop perhaps. We can now make direct calls to the public API. So we could do something like set current limit. We don't need to worry about handling any visa references in test stand. We can just make calls to the public API of our DQMH module directly from test stand. Set update current limit was my method. I didn't give it the best name. And I can provide the current limit. In this case, let's set it to 0.5 amp. No references required, and I think you'll agree that this simplifies the programming from a test stand perspective, not having to worry about the references, etc. And it means that I can do the interactive debug of my API directly from my API tester in LabVIEW before making calls to it from test stand. So I'm not having to worry about writing wrapper VIs or anything like that. I'm calling my API directly from test stand. A nice feature of this is that the API tester, because we're using user events under the hood, the API tester can be used as a sniffer. So I can execute my test stand sequence and in parallel execute my API tester, and I could use this to inject values, to change values, or to actually sniff values being returned from the DQMH module to test stand. I can actually use my API tester as a sniffer to sniff those values, or maybe actually alter the behaviour. So the interaction with my module, should I require additional diagnostic functionality or interaction with the device under test, for example, as an engineer, becomes greater because I have the availability to run the API tester in parallel for each of my DQMH modules, in parallel with my test stand execution. I hope you agree that this gives us the benefits of the LabVIEW debugging environment and lets us take advantage of our LabVIEW based code from within test stand with minimal reworking, and allows us to take advantage of those great test stand features such as reporting, user management, database logging. If you require more information, have a look at the shipping examples that come with DQMH. Like I said earlier, we have 3 great test stand examples in there as well to show how you can use DQMH to help your LabVIEW development and use it in test stand. Thanks for watching.